Welcome back to Chem with Kess, as again, I know you're all tired of me and these alkenes, but I promise you it really is helpful. When it comes to this reaction, it is called hydroboration. Hydroboration is also underneath a category called hydration. Hydration is the addition of water. In this case, when we add water for hydroboration, this OH group will always go to the least hindered side, or the less stable, whichever terminology you're comfortable with. And if they ask, because I'm not going to go over the mechanism in this video, normally teachers don't tend to test you on that. I shouldn't really tell you this, but just let me know in the comment section if you need me to go ahead and work out this mechanism, because you're a visual person and needs to see it. It's no big deal. So when it comes to this one, you're going to go through syn-addition, which means we're adding things on the same side, which is the same thing as cis, in case they want stereochemistry. But the big important factor to note is that it goes to the least hindered side. So as soon as I come over here to categorize the type of carbons I would have if I were to remove the double bond, the left side is tertiary, the right side is secondary. So I'm expecting my OH group to go to the secondary location. So that means my answer would look like this. I know I make it look simple, I do. Now, if they wanted stereochemistry, you would note that, again, just to show you both ways. And either way is correct, by the way, so you do not have to worry about, is there one or the other a better way to draw it? Nope. So still the ones on the bottom, the OH group still gets added to the least hindered. But again, now for the stereochemistry look, we want to follow the fact that they're cis. So that means I'm making both of these either wedges or I'm making both of them dashes. And the reason, so you also know, when it comes to like, why did I draw the hydrogen this way versus this way or that way? It doesn't necessarily matter. I just go by the peak. So if the peak is already occupied with something going this way, I just still make sure to put my hydrogen upward versus like this peak is going downward, hence why that OH is just facing that way. Now, what if I have an alkene that looks like here? Now, this is primary on the end, and the one in the middle, closer to the inside, is secondary. Now, if I decide to do this reaction, how does that change things? So what's important is understanding, do not lose a carbon. I tend to tell students to count because for some reason, we will mistakenly lose a carbon at times. So I know that my OH group needs to go to the number 1 position, so I would draw the OH coming off of 1. I've had students do it like this, which is the wrong way, but you know what? I'd rather show you the wrong way so you can catch yourself from doing it, but they'll quickly draw the picture and try to put an OH right here as the answer. But again, this is wrong. Now, why? Because when I look at it, technically, you would say, okay, I put the OH at the number 1 position, but did you? Because really, this right here is not a carbon. Your first carbon would start on the outside, so you have now essentially lost a carbon. So sometimes when you look at your problems or your teachers grade them and you're like, what went wrong? They're not obligated to give you those points back because you literally changed the structure of the original picture that was given. So just make sure you do not do the wrong way. And it happens, but with practice and patience, you'll get there.